Okay, this is just going to be a short video on something which you haven't come across before. It's called water crystallization. Now, if you can probably guess the what this stuff is on the left here, you know what that is. That is copper sulfate, yeah? And the formula of copper sulfate is CuSO4, of course, but in actual fact, this blue copper sulfate here, the one that we're most familiar with, when you get it, it has, for every one copper and one sulfate ion, it has 5 molecules of water trapped in the crystal structure. Okay, so the ionic lattice of copper sulfate actually always has water molecules trapped in it, and it's always exactly 5, and they're not just put in any old way. It's a regular geometric arrangement, and that's why it's always 5. This value, this number 5 here, is called the water of crystallization, and it can be. It's nearly always a whole number. It is always a whole number, really. For example, there's a couple of other ones here. Magnesium chloride. Hydrated magnesium chloride actually has a water crystallization of 6, so that has 6 H2Os in it. I think magnesium sulfate has 7 waters, I believe. Nickel sulfate, that also has 7 waters. Some things have 1, 2, even numbers up to about 12 sometimes. Okay, so an awful lot of ionic compounds, not all of them, but a lot of them come as hydrated salts. Okay, so this is the hydrated salt. And you will have actually come across this, I think, probably towards the end of GCSE or about reversible reactions. If you heat up hydrated blue copper sulfate, you get this white stuff here, and this is anhydrous copper sulfate, so it's got no water in it, and it's a different color. It's white. If you add a little bit of water back to this, it will turn back into that blue stuff there. Right, now that's quite important, because saying if I'm weighing out, say I've got a pot of of copper sulfate. It's called copper sulfate pentahydrate. Okay, that's its proper full name. I've got a bottle of it. Okay, and I want to weigh some of this out. I want to weigh out 1 mole of this stuff. Now, you may think, okay, so moles is equal to mass over mR, isn't it? We want 1 mole, and so the mass for 1 mole, mass equals moles times mR. We've got 1 mole, it's 1 times the mR. So in other words, if we weigh out the mR of that, then we'll have 1 mole of copper sulfate. So if I worked out what is the mR of copper sulfate, well, it's 63.5 for the copper, plus 32.1 for the sulfur, and then 4 times 16 plus 64, that is 159.6. Okay, 159.6. So if I weighed out 159.6 grams of this stuff, I'll have 1 mole. But that would be wrong, because I'm forgetting here that it's not copper sulfate, is it? It's copper sulfate with 5 water molecules in it. So if I only weighed out 159.6 grams, I would have less than 1 mole of copper sulfate, because a lot of that would just be down to the water. I wouldn't be just weighing out copper sulfate, be weighing out water. So really, when you work out when you think about the mR of the hydrated thing, you must work out of the whole thing, of the copper sulfate and the 5 H2Os. Okay, so that is going to be 159.6 plus water's 18, isn't it? So 5 times 18, which is 90. So that's going to be 249.6 is the mR of hydrated copper sulfate. So if I wanted to weigh out 1 mole, I'd have to weigh out 249 grams, yeah? If I only weighed out the 159.6 grams of it, I'd have way less than 1 mole. It's only about 2/3 of a mole. So when you're using hydrated salts, you must always, when you work out the MR, you've got to take out you've got to take into account the waters there. So let's just do that. Magnesium chloride 6H2O, what's that going to be? The MR of magnesium chloride 6H2O. Magnesium is 24.3. Chlorine 35.5. And then each water is 16, so that's 6 plus 6 times 18. That's going to be equal to 203.3. Okay, very important to remember the waters in there when you're working out the MR of these things. One more thing I just want to talk about when, and this sometimes causes a bit of confusion. If I get some, say I'm going to make up a solution of, so I want to make a solution of 0.1 or mole per decimeter cubed copper sulfate. Okay, so when let's say we were going to make it in a volumetric flask, in a 250 centimeter cubed volumetric flask. So I'd need how many? What would I need? I'd need, so moles is going to be equal to the concentration times the volume. Well, the concentration we want is 0.1 and the volume is 250, so that's going to be equal to 0.1. Volume in dm cubed is 0.25, so that's equal to 0.025 moles. Now we need to work out the mass of that. So the mass is going to be equal to the moles times by the MR. So 0.025. Now the MR of copper sulfate pentahydrate, we worked out before, is 249.6. So that's going to be times 249.6. Okay, 0.025 times 249.6. That's 6.24 grams. Okay, so that needs to be of copper sulfate pentahydrate. We need to get that much, dissolve it in water. Now, when we get, let's just think here. So I've got copper sulfate dot 5H2O solid, and I'm going to dissolve that in water. So it's going to go to CuSO4 aqueous, and those water molecules are going to be released, aren't they? Okay. Now, some people get a bit confused about these water molecules. You've got 5 water molecules per copper sulfate. This amount of water is quite trivial compared to all the other water that you've added to make the solution. Okay, so if you could maybe visualize it, you know, we've got a little bit of copper sulfate there, and we're going to put that into a much, so that's going to be a little bit of water there. It's going to be loads of water molecules in here. Yeah, so you're going, well, that goes in there. But then you're going to add loads and loads of water, loads of H2O in there, aren't you? And so this will, it's no longer hydrated copper sulfate. When it's in a solution, the water molecules aren't stuck with it anymore. They are just mixed up with the rest of the water that you've made the solution with. Okay, let's leave it there. In the next video, we're going to work out, using a titration, the water crystallization of a compound.